little bit of practice so that you guys are able to feel comfortable with what we're doing. I know these are not always easy, unless you've chewed on them a couple times. So, the first one I want to share with you guys is going to look like this. Okay, when they're given to you in AX plus BY equals C form, or otherwise known as standard form, I convert them into slope-intercept form, which is Y is MX plus B form. So I would convert this one by subtracting 2x, making it Y is greater than negative 2x added to 1. I would do the same thing over here, but you always want your Y to be positive. So you could either subtract your x, and I'll show it to you that way. Subtract your x, and then divide everything by a -1 to flip it. So if you divide everything in here by a -1, it flips all of the symbols and the inequality, making it Y is greater than or equal to x minus 3. Okay? I divided everything by a -1. Sometimes you don't even have to, some people don't even have to think of it that way. They just know they're going to flip it. Okay? So to keep it nice and clear, I love to use multiple colors. You can use pen, you can use whatever you like. I'll start with that one. Okay, so if my y-intercept is a 1, that's here. And if my slope is -2, that means down 2, right 1, which puts me here. And I'm going to decide, is it dotted or is it solid? Dotted, because it's only greater than. It's not also equal to. So this is the graph for y is greater than -2x added to 1. Let's test the 0, 0 because it happens to be right here. Okay, so if the 0, 0 is true, we're going to shade to the right. So 0, 0. 0 is greater than -2 times 0 added to 1. Is 0 greater than 1? No, it is not. False. So do not shade in the 0, 0 side. Shade in the other side. The red indicates what is true. Okay? 0, 0 was false for this one, so we shaded over there. Now the other one. Y is greater than or equal to -x minus 3. So -3, 1, 2, 3, and slope is 1. So up 1, right 1, like that. Solid or dotted? Solid. My line's not real pretty, but it does the job. Should we test 0, 0 again? Let's do it. 0, 0. Filling in the rest of the equation. 0 is greater than or equal to 0 minus 3. 0 is greater than or equal to a -3. True. Which means we do shade in the portion including the origin. The only time this doesn't work is if the origin is on the line. And if the origin is on the line, choose something else. Choose another pair of points that you feel is easy to do. Any pair of points will do. So that means this area here is true for both. This is only true for the red equation. This portion is only true for the blue equation. This portion is both, and this portion in the white is neither. You could plug in anything in the white and neither would be true. Okay? Any questions on this sample? Oh, I forgot to write in the other equation. Y is greater than or equal to x minus 3. All right. Moving on to the next one. My next inequality system is going to be this. X minus 6, or x is, less than 6. X plus y is greater than 4. Finally, y is less than negative 1/2 x plus 4. Isn't this one pretty? It's already ready for you. That makes me happy. So we'll start with this one. My y-intercept is a 4. And I'm going to use yellow. Why? Because I want to. 1, 2, 3, 4. And my slope is -1/2, which means down 1, right 2. Down 1, always right. The second number is always right. It's the numerator that dictates up or down. Solid or dotted? Dotted, because it is not also equal to. I love working with multiple colors. I just feel like it looks like we're really doing something. All right, should we test 0, 0? Looks like a convenient spot. 0, 0. And once we figure out what to shade, I'll decide where to write the graph. 0 is less than -1/2 times 0 added to 4. 0 is less than 4. 0, okay, thank you. I got a little confused. I thought maybe I have missed the boat. True, so we're going to shade yellow down here. You don't have to spend a lot of time on your coloring. Okay? So I'm going to write that equation up here. I'll do it up here. Y is less than -1/2 x plus 4. Y is less than -1/2 x added to 4. All right. X is less than 6. Let's do that one next. Let's do that one in red. That means X always has to be anything below a 6, and that is your right-left movement, right? So 1, 2, 3, 4, 5, 6. So this is 6 for X. So is everything on this line. Dotted because it's everything below a 6. X is less than 6. Do I really need to test it, or do you guys recognize that you shade everything to the left? Yes? All right. So that is going to look like this. Oh, aren't the colors getting interesting? So far we have this yellow line and everything here shaded yellow. We have this red line and everything to the left shaded. Finally, this one. We'll solve that one by making it y equals mx plus b. Y is greater than -x added to 4. So 4, 1, 2, 3, 4. I'm going green. 1, 2, 3, 4. It shares the same point as that other line, doesn't it? And down 1, right 1. And if I were you, I would do a couple of points because it starts off looking like it's the same line. but it's not. It kind of opens up. Solid or dotted? Looks like it's dotted, doesn't it? I've already kind of drawn it. So, yellow line, green line, red line. Should we test 0, 0? Sure. 0, the opposite of 0, which is 0. 0 is greater than 4?
No.
False. Which means you shade everything to the right. Now, it's probably difficult to see because there's so much going on. But the portion that satisfies every single one is found between here, here, and here. Because this is the yellow, red, and green. So this portion is the only portion that satisfies all three equations, inequalities. Okay. And I will be looking for that. You recognizing what satisfied all three. And that's why using different colors makes it easier. I mean, it's easier for me to see up close, but when I look on the screen and look up there, I don't know, maybe you guys can see it, but it looks hard to see. All right, so that is a 3-part. 1. How you guys feeling about these so far? You guys want to do another one, or do you want me to quit?